Hello, everyone, and welcome to the PROSTHONEXUS masterclass on recent advances in prosthodontics. Before I begin my lecture, I would like to extend my heartfelt gratitude to the team of HKE Dental College for organizing such a meticulous program, and thank you for the opportunity provided to me. Going forward, I always believe in this dictum that you cannot use yesterday's technology today and expect to be in business tomorrow. Now, prosthodontics has undergone a massive change in terms of techniques, technologies, and it's a evolving process. It's a very dynamic science, and thing is, it's not just about materials, but there are multifactorial uh, factors which are there which influence the final outcomes as well as the longevity of a particular treatment option that we have provided to the patient. Now, the advantage of digital workflow, which has been in vogue nowadays, is that it has helped us to improve the outcomes and make it much more predictable in terms of what we are able to deliver to the patient, while also shortening the turnaround time. That is, it has brought down the amount of time required for the process to be complete. So I have broadly divided my today's lecture into five aspects. That is the advances in materials, advances in techniques, advances in digital workflow, emerging trends in AI or robotics, and sustainability in prosthodontics. So let me begin with advances in materials. Now, coming on to the one of the most versatile and highly used material nowadays, that is zirconia. Now, what exactly is zirconia? It's a crystalline oxide of zirconium material. Now, it is majorly used in prosthetics for aesthetic, biological, and their mechanical advantages because they have a very good strength as well as good aesthetics. So it's a combination of both good strength and good aesthetics. So they are available majorly in 3Y TZP form, which is the conventional zirconia which was brought into dentistry. But zirconia by itself, the nature is that it is a little opaque material. So they have very high strength. The 3Y TZP has high strength, but they have less amount of translucency, thereby limiting their options in terms of where we could be applying these materials. So they were mostly restricted to implant frameworks or posterior restorations, or they had to be layered with ceramic where if they were used in aesthetic zones, because you cannot use monolithic zirconia 3YTZP in aesthetic areas because of their opacity. So that is where material underwent some amount of change, and there was an increase in the yttria content which was provided to this material, because of which newer materials like 4Y and 5Y partially stabilized zirconia was brought in, which increased the translucency for anterior aesthetics, especially as monolithic restorations. But again, the advantage of aesthetics came in with a compromise of strength. So in terms of strength, the 3Y TZP is much lower compared to that of the 4Y and the 5Y partially stabilized zirconia. Now, if you're looking at this family of zirconia, so you have three different types, which is monochromatic and the uniform composition. Basically, it is one type of material. So either it is 3Y or it is 4Y or 5Y or 6Y. Now, these kind of blanks are called as single composition blanks. So these blanks do not have any change in the color or their material properties. They are completely made of one particular type of zirconia. But then you have polychromic multilayer but uniform composition, which is again, they have gradients in terms of color, but the composition inherently remains the same. So if you are looking at a 3Y, it will be a 3Y only all throughout. But you have some amount of gradations which are there in terms of the color as you go much higher. But in polychromic, multilayer, and hybrid compositions, you have different compositions of materials which have been put into the same disc, which gives you an inherent amount of advantage in terms of its properties as well as its aesthetics, because of which there is a difference in these materials uh, in terms of what they offer. So you have monochromatic and uniform composition, you have polychromic multilayer, and you have polychromic multilayer with hybrid composition. So as I was telling you that 5i TZP is more translucent because of the lower ETR content, and they have less flexural strength by about 40 to 50% compared to that of 3y. Now, one of the key properties of zirconia is that they have good flexural strength, excellent fracture toughness due to transformation toughening. They are biocompatible and they have a property of minimal plaque accumulation. Now, this has been shown in various studies in literature, and they are more resistant to wear and but causes antagonistic wear if you have left the surface rough. If your surface is not rough, if it's well polished or glazed, the antagonist wear has been shown to be very similar to that of any other ceramic materials. So that is a myth that zirconia by itself tends to wear the material or the antagonist tooth much more compared to other materials. It happens only when the surface is left rough. Also, they have low thermal conductivity, because of which it is a more preferred choice for vital teeth restorations because of its favorable affinity to maintain pulpal health. Also, they have excellent aesthetics because they are without metal substructure, and they have an inherent ability to mask the underlying discoloration without any metal usage. Also, they are more CAD/CAM friendly because of their high milling accuracy and reproducibility and low failure rates. And long-term marginal adaptation and mechanical stability is very good, with improved processing efficiency via digital workflows. But every good has a bad in it. So you have layered zirconia. Sometimes, when you are applying an additional layer, they may tend to suffer from chipping of zirconia, because the zirconia by itself does not is not a great material for ceramic to be layered on. So it is all done by chemical treatment. So that is where the problem lies, that sometimes these materials do not have the affinity and they can end up chipping. Also, they have lower translucency compared to that of ceramics, which are lithium disilicate or any other ceramic materials, which tends to give you much better aesthetics compared to that of zirconia. Also, their intraoral adjustments are a little more difficult because there is a tendency for a risk of surface damage, which can propagate as cracks and could lead to fracture of the restoration down the line. Especially when you are adjusting zirconia, make sure that you are adjusting it under copious water irrigation, because heat again propagates the cracks to increase in size. Bonding challenges are there because zirconia by itself is not a does not have a glass interface like lithium disilicate, which makes it very difficult for this material to be etched. So basically, what we do is we do air abrasion plus apply a layer of MDP primer, which helps us to ensure the bonding of this zirconia to a tooth. Next, we come on to sintering. Now, sintering can be done by two types. One is conventional and one is speed sintering. So, the conventional is done with lower temperatures but longer times, typically about 6 to 7 hours to achieve full density. And speed sintering is done about 1550 to 1650, and you have shorter hold times. So, basically, about 1.5 hours, the whole process is complete in speed sintering. So studies have been shown comparing the slow versus fast protocols. Now, certain advantages are there with slower protocols, where you have larger grain size and higher translucency. But speed sintering has a improvement in biaxial flexural strength. Also, they have less dimensional changes. Some studies have shown that there are minimal dimensional changes between fast and normal sintering protocols. So Next, coming on to the luting or bonding to zirconia. So here we have, as we discussed, we have the regular zirconia and the uh, uh, high translucent zirconia, which is 5i TZP. So the high strength zirconia, that is the regular zirconia, is basically you could either lute it or bond it. So if you are looking at bonding it, again it's the MDP primer along with air abrasion. But in 5i TZP, the strength is much lower. So it is more preferable to only bond 5i TZP and not lute 5i TZP with glass ionomer cements, which is not the case with 3y TZP. So 3y TZP, you can lute it with glass ionomers or any other cements, but 5y TZP, it's only bonding because of reduction in the strength of zirconia. Next, we come on to high performance polymers, which is BioHPP and PEEK. Now, BioHPP is basically a modified version of PEEK, which has got ceramic fillers. So, the advantage of this particular material is that they are mainly used in implant supported prosthesis and RPD frameworks, and they are biocompatible, non-allergenic, alternative to metals, and they adjust chairside adjustments are a lot easier, but their polishing or aesthetics is much weaker compared to that of ceramics. Now, long-term data is not there, but this is a relatively newer material. But the initial results have shown a lot of promise in terms of their material behavior. So the key property here is that they are peak matrix with about 20% of ceramic or microfillers which are used, which improves the strength of this material and also gives it a bone-like elastic modulus about 10 to 15 gigapascals. So it basically has a shock absorbing behavior which is closer to bone than compared to metals. So in terms of mechanical performance, they have a good bending strength, high impact resistance, and low wet abrasion wear. And they mainly used for bars, frameworks, and milled restorations. And in terms of biocompatibility, they have excellent biocompatibility with low cytotoxicity and are having good soft tissue response compared to that of metal alloys. They are also extremely lightweight, thereby their advantage of using a BioHPP as a framework for implant restorations is that the weight of the prosthesis tends to come down drastically. In terms of its clinical applications, they are used in implant bars, hybrid prosthesis, fixed and removable frameworks. You could use it as inlays in posterior restorations, veneering and bonding, and primary and secondary coping for implant overdentures. Also, in terms of the advantage is again the low weight, which again reduces the weight of the prosthesis. They have a favorable modulus, which is very similar to that of bone. So there is a favorable load distribution in terms of this using this framework. They have good aesthetics when they are veneered, and they have radiolucent that is they do not have any kind of ferromagnetic properties, and they have a reduced galvanic and metal allergy risk, thereby improving their patient acceptability. The limitations are that they have low absolute rigidity compared to that of metal. That is, they have certain amount of flexion which is there in them, and especially in long span heavy load cases, sometimes it could be an issue. Also, their wear behavior under dry abrasion is variable. That is, this material may not exactly give the same kind of output when you are looking at milling this restorations, if not for wet milling. Also, they are technique sensitive. Now, this material can either be milled or pressed, just like lithium disilicate. They can be pressed as well. So when you are looking at pressing PEEK, the problem with pressing of PEEK is that sometimes this material is technique sensitive, so it can give problems when you are pressing it if the pressure and the material heating is not proper. Also, surface bonding and surface prep is required before you can achieve a predictable bond strength. Also, long-term data, that is 5 to 10-year clinical data, is still limited because this material is relatively new. Also, as if you are looking at bonding this material, because the best clinical performance is achieved only by bonding, you need to condition and then prime the framework first. Conditioning is done by sandblasting it with 110 microns aluminum oxide at about 2 to 3 bar pressure without using any kind of steam post the sandblasting. And then you need to apply a primer, which is basically visual and then do a light curing at about 372 to 400 nanometers for about 90 seconds. After that, you need to apply the conditioning for the copings as well, where you are sandblasting and then you are applying the primer. Once the priming is done, then we are applying a cement called as DTK adhesives to bond the two parts together. And then you are luting the superstructure, that is either HIPC or ceramic or zirconia, whatever it is, to this bio HPP framework. So that is where it will achieve its maximum strength. The clinical applications are mainly for implant frameworks, crown and bridges, full arch prosthesis for implants, and mainly implant abutments. So this material is manufactured commercially by a company called as Brident. Now, Brident is having most of these components for bio-HPP, for implants, and they even have these premils which are there, so you can customize this material for implant abutment according to the requirement. Next, we come on to hybrid ceramics, which are often called as polymer infiltrated ceramic networks or PICNs. So these materials are a combination of both your ceramic and your composite. So they have 86% of ceramic properties and about 14% which is there of your composite. So when these two materials are combined together, they give you a material which is very good in terms of aesthetics, in terms of versatility, and in terms of their clinical performance as well, and especially repairability when you are looking at uh, this prosthesis. Now, if you are looking at this table here, which is comparing lithium disilicate zirconia along with the two newer materials, that is hybrid ceramics that and polymer infiltrated ceramic network and HIPC, that is high impact polymer composites. Now, what we need to understand here is that your high impact polymer composite is basically a cross-linked polymer matrix which is reinforced with fillers, whereas your hybrid ceramics are basically a ceramic network which is infiltrated with polymer. I told you the ratio about 80 to 20. 80% of ceramic with 20% of your fillers. Whereas lithium disilicate zirconia is more of ceramic and polycrystalline zirconium dioxide. So they have an inherent property of brittleness, though they have very good strength. But in terms of your elastic modulus, you have a much better elastic modulus, which is very close to dentine in your hybrid ceramics when you are comparing it to your lithium disilicate and zirconia. And that is where it is very favorable in terms of its antagonist wear also, where which is more enamel like, because it has a property which is both of ceramic and zirconia. Their repairability is excellent, so you could repair these materials with just using your conventional composites. Unlike your zirconia or your lithium disilicate, both HIPC and your hybrid ceramics could be repaired with your conventional composites, and they have very good aesthetics. And the only disadvantage or limitation, I would say, when you are comparing these materials with your zirconia, is that they are unable to be given in multiple units or long span, because they do not have the high load. But the advantage is that they could be bonded, which gives it a very distinct advantage, because you could use them for partial veneer restorations, and you need not go ahead with your regular full coverage crowns. So you could help save a lot of preserving a lot of enamel in the process, as well as the tooth structure, where you are just doing a incremental build up and not reducing the tooth structure. So advantage is there with both hybrid ceramics and HIPC, but understand that HIPC per se does not have any ceramic content in it. They are purely composite materials which are reinforced, and your hybrid ceramics have a combination of both. So in terms of these two materials, when you're comparing them to the other regular materials like lithium disilicate and zirconia, they are much less brittle compared to these materials because of their inherent resiliency which is there in them. So if you are looking at practical applications of these materials, you use a polymer infiltrated ceramic network, that is hybrid ceramics, when you want conservative, repairable, enamel friendly restorations for partial coverage where you are bonding them. And you are using lithium disilicate when you need better strength and aesthetic longevity with your single crowns or ceramic veneers. When you are using any restoration where there is high loads, you are looking at zirconia or your posterior full crowns or your long span frameworks. So you are preferring zirconia at that point in time. And when you have a resilient, easily adjustable polymer solution, for example, in some long span implant frameworks, which are underneath the bio, which are layered over a bio HPP framework, at that point in time you are looking at a high impact polymer composite, or you could even be looking at high impact polymer composite for a long term temporary restoration. So they work phenomenally well. In fact, I have used them in a few of my cases and they work brilliant. So I don't see a reason why they can't be used in your regular fixed process cases. Only thing is you cannot give them in long span. They can be used for partial veneer or they can be used for your regular crowns. But again, the problem is that you can't have very high loads in these areas. Next, we come on to your bioactive and surface modified materials. Now, bioactive uh, materials are nowadays incorporated in cements, which are mainly bioactive glasses and calcium silicate cements, which enable ion release. Now, the advantage with incorporating bioactive cements is that you have bioactive materials in resin cements or your regular glass ionomer cements, is that you have some materials which are providing ion release which can reduce post operative sensitivity. Also, these newer modified materials are also used in terms of bone and tissue healing as well as potential socket preservation, especially in bone grafts. Also, the newer material called chetosan, which is there, is used as a coating over abutments and frameworks to improve soft tissue adhesion and give a better soft tissue response. So, all of these newer materials, though have been experimented with and have given favorable results, they are still under clinical research on their long-term capabilities, and there are very few randomized control trial studies which are available for us to be, speaking about them with certain degree of conviction. Also, if we are looking at the recent clinical techniques, we are looking at guided implant surgeries, which I'm sure most of us have used this at some or the other point in time. So basically, these kind of guides that you're seeing on the screen are called as static guides. Now, these guides are basically designed and customized according to the patient's requirement. Now, these are made prefabricated, that is, they're kept ready before the procedure, and they are widely used nowadays simply because they reduce the chairside errors which can go wrong during a surgery, because you are virtually planning the implant placement and then you are going ahead with the execution in the chair side by seating this particular guide. So it makes it very important that especially when you are going near a critical structure, you need predictability to ensure that nothing goes wrong. So these guides help you ensure that you are able to achieve that. Also, your surgery tends to be much faster, and especially complex cases like full mouth rehabilitations, it brings down the patient fatigue, the operator fatigue to a great extent, simply because the whole procedure is guided and it is sometimes flapless as well. Now, there are certain limitations to this as well. One is the cost, because there is an additional cost involved for the guides to be fabricated. You have a learning curve which is associated where you are going to design these guides. You need to understand EXO plan or any other guide um, uh, planning software, and also you need to make sure that your imaging is spot on. So you need a CBCT scan for this, and you cannot work without a CBCT scan, uh, which is incorporated into your software. So you need to import the scan into the software, and only then you are able to execute the whole planning process. So I'll just share with you one of the cases that we had done using this guide. So this was one lady who had come to us and had a missing central, and then we went ahead and we planned it, and she didn't want to walk out without a tooth being there. She was wearing a removable. She said, no, I after the implant is done, I need to make sure that I want a fixed solution itself. So we had to make sure that we are giving her something fixed in the prosthesis as well immediately. So we planned the implant placement using the guide, and went ahead and got a abutment milled as well, and a 3D printed crown ready as well. So this was the final outcome, and the patient walked out with the final prosthesis, not the final prosthesis, the temporary prosthesis, which was seated there immediately post, sorry, immediately post surgery. So that is the advantage what a surgical guide planning can give you, because you are able to execute the whole process right up till the crown using the software, and you are able to plan the whole process reverse, and you can do it with a certain degree of predictability. Now, here, of course, single implants we could easily manage with your regular tooth-supported guides. But how about a full mouth? So at that point in time, when you're planning, you need to look at something called as stackable guides. Now, the advantage or the reason why we use stackable guides is mainly because number one, when you are looking at some amount of bone reduction in the patient post your extractions, or you have a very limited prosthetic space, you need to make sure that you are reducing the bone perfectly well, so that your prosthesis, which is fabricated, is seated predictably. Now, how we go about the whole process here is that the first time you seat your bone reduction guide, to which the top level you reduce your bone, following which you seat another guide which seats on top of this guide, and you are able to execute the further procedures of implant placement, your prosthetic seating, your component seating, everything, while keeping the primary bone reduction guide in place, because those guides have the attachments onto which the other parts will come and sit of the other guides. So it helps us in having a predictability when we are looking at multiple positions where you are looking at seating a implant. So that is the advantage. I'll just speak to you regarding this. Now, see, for this case, if you're looking at this case, now there is multiple teeth which are there. So you need to make sure that you are removing these teeth. Now you need to adjust the prosthetic platform also of this bone, so to make sure that you have enough space for a hybrid prosthesis to be given. Now, when this will be achieved by using this bone reduction guide, the first guide which is placed. Now, once this guide is seated there, once the bone is reduced to that level, if you are seeing here, these pins which are there will have a female component in this guide, which will enable this to be seated perfectly, and through this there will be drilling done, and the implants will be placed in their planned positions, after which the prosthetic components will be seated there in their planned positions, and then finally the prosthesis here again is seated in a predictable manner into these planned positions. So these pins basically will or these pins here will help us guide each of these components predictably into the same position, thereby making sure that there are no errors incorporated. So that is the advantage of the stackable guides, and this brings down the surgery time as well as the prosthetic fabrication time drastically down, especially in a full mouth rehab case. Next, we come on to partial extraction therapy. Now, I'm sure you must have heard about partial extraction therapy. So here, what we do is that we know that immediate extraction is the norm nowadays. Most of the patients look for immediacy. Now, are all candidates or all patients a perfect candidate for immediate implants? We don't know. Now, what we need to evaluate here is that how much of buccal bone is available there. Now, if your buccal bone is too thin, you can expect a resorption, and no matter what you do in terms of your grafting there, into jumping distance and everything, you will still see that there is a loss of your normal gingival architecture when you are looking at this during 3 to 4 months down the line after immediate extraction. So what you need to ensure here is that you are leaving behind your part of the tooth, the labial portion of the root, intact to the bone, and removing the other part and then placing an implant. Now, what this does here is that this labial portion of the tooth that is left behind attached to the buccal bone tricks the body into believing that the tooth is still present there, thereby does not allow the bone to resorb itself. So that is a distinct advantage, especially if you are looking at a very sensitive aesthetic zone case, and especially with a thin biotype. Your gingiva generally has thick biotype and thin biotype. So your thick biotype generally has very less resorptive potential, especially when you reflect it. But your thin biotype, the bone underneath that is also usually thin, so it tends to resorb very easily. So here you are not looking at removing the tooth completely, but leaving that tooth attached to the buccal bone behind, so that the body is tricked into believing that your tooth still exists, thereby preserving the buccal bone architecture. Now, one thing you need to ensure here with this particular procedure is that you are leaving behind the tooth attached, and make sure that it is not mobile, and also your implant position has to be in such a way that there is some small amount of gap that is left behind between the tooth and the buccal surface of the implant. So here we classify it according to these particular processes. That is socket shield technique, where we are leaving behind the tooth portion on the anterior segment, that is the buccal side. Then we have something called as root submergence technique, where we are leaving behind intentionally a vital tooth or a non-vital tooth below the mucosa to preserve the pontic site, usually done under FPDs, sometimes under implants. And we can also do something called as pontic shield, where it is a modification of the socket shield, where a root fragment is left behind to support the pontic site. Now, the whole process remains essentially the same, except that there is no implant placed in that particular socket. The remaining process is the same. Only the buccal shield is left behind, but it is a site where a pontic is going to come and not an implant is going to come. Okay, and then you have a combination of these different approaches which can be used. So mainly we use this in aesthetic areas where we are looking at a thin buccal plate where there is a risk of resorption. Basically thinner than 1 mm, then you are definitely looking at a resorption risk with your buccal plate. So you can assess that in your ZBCT, and then you can plan for a socket shield. Also, when you are looking at aesthetic areas which are critical, especially your central area where the patient is highly demanding and you need to preserve the interdental papilla and the buccal tissue contour, then you need to look at socket shield. And mainly where you are looking at no extensive grafting as well in the particular patient. Contraindications is when you have acute infection in that particular tooth, any kind of mobility or vertical root fracture when you are there, when you are having in that particular patient, please do not use socket shield over that particular tooth. Also, buccal root dehiscence, if it is there, or perforation which is there, then it is again going to be an issue. So you need to make sure that you are taking that root piece out. Also, if you this is a very technique sensitive process. So when you are looking at slicing the shield or creating that shield, you are going into the root area and you are sectioning the root. Now, when you are sectioning the root, you have to rely on one, your tactile feel, and two, your X-rays to make sure that the root is completely sectioned. So when your root is not completely sectioned, and when you are trying to remove the palatal portion of the root, sometimes the whole shield can also move at that point. So if you are having a shield which is moving, please do not leave it behind. You need to remove it out. So that is another thing. Also, patient factors where you have smokers, uncontrolled diabetics, and any other standard implant contraindications are there. Please do not go ahead and use this particular technique. This is only where everything else is spick and span, very healthy. Only then, in those clinical situations, you are going ahead with this particular procedure. The advantage is that there is a buccal bone resorption which is reduced drastically. Also, there are improved aesthetic outcomes because the buccal bone contour is preserved, and there is a reduction in the requirement for a buccal grafting, which is there. So, a lot of studies have been done. Now, earlier there were only some few on and off clinical reports which are coming through, but of late there have been systematic reviews and meta-analysis which has come, which have shown a very high survival of implants when these procedures are done. So and excellent outcomes in terms of soft tissue as well. So there is a distinct advantages, and there are limitations there, that this whole technique is very technique sensitive. Also, the evidence is very heterogeneous. That is, it is not it is not very like all the literature is not completely vouching for saying that this is very successful. Some says it is successful, some say it is not. So where you tend to believe that you have success, you have to really look into the literature and then decide on whether this is applicable to your clinical case scenario or not. Also, complications such as shield exposures have been reported, and also these are relatively newer procedures which have been initiated recently. So you don't have long-term outcomes beyond 5 to 7 years. So when you are looking at long-term outcomes, you're looking at 10 plus years. So you need to make sure that you have more long-term data before you can propose this as a treatment plan. So this was one of the cases which we had done. So I'm just sharing the pics here. So this was shield which was sliced, and then afterwards we had extracted the palatal portion. Then we thinned down the shield, and then we placed the implant, and we went ahead with the healing abutment placement. And this was the final restoration given on the lateral incisor. If you're seeing here, it has got excellent contour in terms of its buccal bone, which is there. Even this implant also was this one shielded, so it has excellent contour in terms of its buccal bone. If you're seeing that, so that is the advantage of preserving the buccal bone there, buccal plate, when by leaving this root behind, because you are able to achieve a much more aesthetic outcome when you are looking at your anterior restorations. Next, we come on to remote anchorage implants. So these are mainly your dental implants which are placed in extra-alveolar sites which are outside the conventional alveolar ridge to engage the basal or the cortical bone. So where your alveolar bone is insufficient for dental implants. So mainly we are looking at something like a sinus. So if you have a large pneumatized sinus where you require a sinus grafting to be done, at that point in time, you are looking at sinus lifts, which is either direct or indirect. So this increases the whole treatment time, plus also reduces the predictability, because you are going to wait for 6 months, plus you don't know whether the implant is going to integrate or not. So this remote anchorage helps us in bypassing the sinus completely, and we are able to engage the uh, basal bone in extra alveolar sites. So basically, we are looking at pterygoid implants, which is engaging the pterygoid apophysis, or it is the tuberosity, which is there. we go through it and then we engage the pterygoid process of the sphenoid bone. Now, this is a tricky process. It is not very user friendly, and it is not for someone who has not done these procedures before with sufficient amount of training. So, a word of caution when we are talking of pterygoid implants is that you need to be adequately trained for it. Also, it is a little blind process, so you need to make sure that you need to know where you are going. So that is one thing. Then you have zygomatic implants, which are basically longer implants which are engaged into the zygomatic bone, traversing through the maxillary sinus. Now, the newer techniques also have classifications which are talking of extra sinus zygomatic implant placements. Now, those are also possible, but basically they are in vicinity with the maxillary sinus. Then you have the nasal floor implants, which are placed in the anterior maxilla, which are engaging the nasal floor, cortical bone of the nasal floor. So this is how a zygomatic implants look. So they could be either bizygoma, which is engaging both the zygomas, or it could be quad zygomas, where there are two zygomas on two zygoma implants placed on each side. So there is four zygomas which are placed, which is going to support the prosthesis. Now the image here is the pterygoid implant. So if you see the final position of your tip of the implant, it is going to engage into the palatine process of the sphenoid bone. So it's a little tricky there, because you have some amount of pterygoid plexus also which is going to be present in this area. So you need to be very careful when you are trying to place these implants, as if something goes wrong, then it could really be drastic. Also, the advantage this remote anchorage presents is that they allow you to use the dense cortical bone beyond the alveolar crest, and it bypasses the regular resorption areas. Also, they are an alternative to grafting, which reduces your treatment time plus also brings down the cost drastically. And these extras, the remote anchorage implants enables immediate loading protocols, because they are engaged into the dense cortical bone, thereby ensuring enough primary stability. So this is a chart which is comparing both the pterygoid and the zygomatic implants. Now, I have majorly spoken about all of this, so you could read it out in the handouts, which I will be, or the soft copy, which I'll be giving to the organizers. So I will go ahead with this. So there are a few studies which are there on the zygoma and pterygoid implants. So these are some of the studies maybe which you could refer to. So these are all the newer studies which we have mentioned, where they have mentioned some amount of predictability in terms of their positioning and your long-term outcomes with zygoma. So then we come on to ultra short implants. So ultra short implants are basically implants with an intrabony length of less than 6 millimeters, which is a minimally invasive solutions for patients with limited vertical bone height, both in the posterior maxilla or the mandible. Now, these are designed to avoid any kind of bone augmentation procedures like sinus lifts or vertical grafting, which is required. Now, the advantage here is that they are ultra short. Now, usually short means up to 8 and below. Ultra short will be less than 6 millimeters. So, these implants basically are more wider and shorter, and they are usually treated with either laser modified or nanostructured or SLA to improve their osseointegration capabilities. Now, clinical evidence shows that the survival rates are very good when we are comparing it to standard implants when used in favorable loading conditions. Now, understand this term, the rider which is there, that it is favorable loading conditions. Also, success is enhanced when it is used in splintered restorations. Basically, it should be a part of a restoration which is multiple units. If you are giving it as a standalone restorations, usually you see reduced success rates compared to that when it is splinted. So I'll just show you one of the cases that I had done with this ultra short implant. This was a 5.2 mm implant which was used in the posterior area, because the the mandibular nerve was very close. And this has been almost 4 years now, and this implant is doing quite fairly well. So there has been no issue in terms of any kind of um, trouble with this particular implant. So yes, when you are using it as a splintered restoration, then yes, it works well. Also, we have something called as zirconia implants. Now, zirconia implants are mainly a viable metal-free alternative to titanium, mainly in sites which are more aesthetically demanding. Now, earlier there was only a single piece or one solid piece implant which was marketed, but nowadays you have two-piece implants also which are coming. That is, the abutment and the implant body are separate. So the main advantage with these implants is that they have excellent biocompatibility with their surface treatment, which is there. And zirconia by itself is a very biocompatible material. So they have very good bone bonding which happens there. Now, disadvantage is that these materials, zirconia by itself inherently is a very brittle material, so some fractures are a common factor which can happen. Also, long-term data is still unavailable because we are only looking at medium-term uh, data, that is about 5 to 10 years. Survival rates are variable, and still research is ongoing on zirconia. I'm sure we will see a lot of improvements in this regard. Also, adhesive and minimally invasive prosthodontics has become one of the most uh, common norms today, simply because of the advent of metal-free restorations. Now, zirconia has, as I mentioned to you, we are able to bond them. Lithium disilicate does need to bond, and same with your polymer infiltrated ceramic networks and HIPCs. So selective etching protocols has enabled us to have less amount of post-operative sensitivity because we do not etch the dentine at that point in time, and also we are able to give a lot of conservative veneer and onlay preparations where we are able to only build up on what is lost rather than grind on what is already present to cover the whole tooth per se. So there is a very important concept in your biomimetic restorations, which is called as biorim. Time is too short for me to explain biorim, but just go back and read on biorim and the importance of biorim in preserving the longevity of the tooth. So, also immediate dentine sealing post our tooth preparation helps us in improving a bond longevity. And the trend nowadays is that we are moving towards minimally invasive adhesive restorations as a permanent solution than full coverage unless and until it is really required. Also, adhesion protocol, if you're seeing with zirconia, mainly we sandblast the internal surface with 110 micron aluminum oxide, clean it in an ultrasonic bath, and apply 10 MDP primer. These are basically primers which can be used in metal as well. And then we dry it and then apply the bonding agent as well as etch the tooth and then cement the restoration. Now, with lithium disilicate and polymer infiltrated ceramic network, we are mainly looking at hydrofluoric acid etch for about 20 seconds to a minute, and then wash and apply the silane coupling on the internal surface of the zirconia, of your lithium disilicate or PICN, and then similarly etch the tooth with phosphoric acid and apply adhesive, and then go ahead and use the resin cement. Next, we come on to intraoral scanners, that is basically digital technologies. So I'm sure we are all well aware of intraoral scanners. So we have seen that they have greatly improved the outcomes as well as the patient comfort, and they have shortened the treatment turnaround times because we are able to provide the same day crowns as well. Their accuracy is very good when we are talking of standalone restorations where single restorations or quadrant restorations are done. But long span edentulous arches, again, it's a little, the process is in progress. We still do not have predictable outcomes in terms of your intraoral scanners. So they have excellent outcome reproducibility, which is compared to or much better than polyvinyl siloxanes. So if you are seeing the advantages here, that no, the digital impression definitely provides a much superior outcomes when you are comparing it to your conventional impression, both in terms of the fit as well as your time as well as your convenience in both the operator as well as your patient. So it is definitely one of the most preferred modes which we have adopted today. So these are all basically the different technologies that the scanners have undergone. So it all began with triangulation technology, which was in the late 80s, in the early 90s, which was the Serec Blue Cam, and then slowly it moved through different generations, and finally we have a different systems adopting different technologies. So we currently have the structured light, the parallel confocal, and the hybrid systems, which are mostly used in different proprietary systems currently in use now. Now, what are the different file formats in an intraoral scan? So every scan file will have three types of files, which is STL, PLY, and OBJ. So STL is basically the universally compatible file format. So this is the file which your software tends to read, or that is what it requires. Now here, this is a monochromic file. So when you are scanning, when you are seeing the gingiva color and everything, it is not the STL file, it is the PLY or the OBJ file, which is rendering that texture and color to it, okay, and making it look much more glamorous. But STL is where the entire data is loaded. So your software mainly requires the STL monochromic file for it to be fabricating the restoration. So here there is something called as dual scan technique, which we use for implants. Now for implant workflow, we mainly need to use something called as scan bodies instead of your impression copings. So first what we need to do is that after we remove the gingival former, when the patient comes for the impression, we need to record one scan of this patient's gingival area as well as the whole arch without the uh, scan body being placed in the area of interest. So first scan is always recorded of the gingival architecture. Then you move on and then you record the impression with the scan body, and then you record the lower as well as, and you record the bite as well. So then these two scans, all the scan files which are combined together, is then sent across to the laboratory, which is then going to utilize this information and then fabricate the prosthesis for us. So the laboratory should have a software which has the library of the implants scan bodies which are used. So you need to mention to them which company, which implant, and which scan body number is used, so that they are able to match and merge the data of the impression scan into their software, so that their position of the analog is achieved predictably. Okay. So this is when we are talking of single implant scans. Now imagine the same scan body being there in multiple positions of the same arch. For example, a full arch restorations. As I told you, full arch restorations do not have the same amount of predictability. So how do you make it more predictable? So we do something called as photogrammetry. Now photogrammetry is technology where we use in full arch digital impressions for implant supported prostheses. Now here what we have is this fiducial markers. Now these markers are placed in the patient's mouth after the initial intraoral scan is done with the scan bodies, and then a image is captured of this using a scanner. That is not the same scanner, it's a different scanner. So they have something called as it's a camera like device which is going to capture this image, and then the two data, that is this data as well as the intraoral scan data, is merged together in the software. So the software will enable the photogrammetry data and the intraoral scan data to be merged accurately, thereby ensuring that the full arch scan is having some amount of predictability. Nowadays, there is a new intraoral scanner also that has come in. which allows the intraoral scan as well as your um, your photogrammetry to be done in the same device. Next, you have the face scanners. Basically, these are non-contact 3D scanning of the facial soft tissues. So here, mainly, it enables us to be doing aesthetic-driven treatment planning and helps us in clarity with communication with the lab, and also helps us improve the patient acceptance. Now, the usual facial impressions is a very claustrophobic experience because you need to put impression with alginate, then you need to put a plaster backing on it. So, patient needs to be given a tube to be breathing it with. So, when the impression is being recorded, so there is a lot of complexity involved in the whole process. Now, facial scans usually smoothen up the whole process and makes it very, very easy. So, if you're seeing here, this is the facial scanner we have in our department. So you are able to just sit in front of the scanner and just move your head gently, and you are able to record the whole scan. So you see the scanner accurately captures the position. So this is the final output in terms of your facial scanners. You can see that the entire data is gathered, and the software will do the analysis, and it will provide you an entire chart of the vertical dimension, the saprophometric landmarks, the distances, the intercanthal distance, the nasion to chin distance, all of it. So the entire data is available with this particular facial scanner. So these are different types of facial scanners which are available in the market today, starting from static stereophotogrammetry, which is one of the most accurate ones, to your mobile devices. So even your Apple phones have certain apps which can be used as facial scanners. To suggest, there is one app called as Qlone, Qlone, Qlone app, which can be used as a software in your Apple phone. It's only on Apple, you can't use it on Android. So some perks of being an Apple user. So you can download that, and you can. It's a paid software, so you can use that. So you have different applications. Mainly in prosthodontics, you can measure your occlusal vertical dimension. You can look at a smile design, or even treat it as a virtual patient, which is there, because you are able to assess everything in the on the screen itself. So mainly with your smile design cases, anterior aesthetic cases. In orthodontics, you're able to do soft tissue analysis and growth monitoring. Implantology, again, your aesthetic planning. And you are able to merge CBCT data, intraoral scans, and face scan together in softwares. So that's a brilliant advantage. So even your gingival crown lengthening, all of this can be planned accordingly. And also helps you to document as well as soft tissue evaluation predictably. Now, digital smile design is basically a workflow which uses photographs, facial scans, intraoral scans, videos to simulate the final aesthetic outcome. So basically, patients today are demanding to an extent that they are asking, what is the guarantee that this is the outcome that we are able to provide? So when patients are willing to go all in, so they want to see what it is going to look like to be able to make a decision. So this software helps us to enable to show our patients what is the kind of outcomes we could be uh, providing to them, which can help them decide on whether to go in for it or not. So first, the key components are digital records, which are basically extra and intraoral photographs, your 2D and 3D facial scans, as well as your CBCT and intraoral scans, which is collected and then it is transported to the software, which where we do the smile analysis, where we are putting the different landmarks, that is the facial midline, interpupillary line, lip dynamics, and dental proportions into place. Once that is done, then you do a smile simulation. So basically, you are able to do a software which is going to mock up. So software is going to mock up the 2D or the 3D preview. where the patient can see the planned outcome. Now, certain softwares also use AI in the process. So they incorporate AI, which is going to do the entire mockup and give you a mock-up where the patient, where you are able to show it to the patient before you even touch a burr on his tooth. So if the patient is happy, certain softwares, the 3D softwares, enables you to even print a model of the same planned outcome, through which you can then finally temporize you after the preparation is done. So even your mock-up headache is reduced because you are able to do the same, you generate the same model as a mock-up of the final outcome that you are desiring. Advantages: it helps you to improve the communication and helps you coordinate the treatment properly, both with your orthodontists, your surgeons. You are able to send the model across to technicians. They are able to see what kind of outcome they need to give. Also, your outcome promise that you are giving with the patients is very, very predictable, especially in terms of your um, shape and size. And patient is also actively involved, so he cannot complain tomorrow saying that it is you who is responsible only, simply because he was a part of the whole decision making process. And also helps you plan this whole thing in a very minimally invasive manner. Now, limitations is that these softwares are expensive, and there is certain amount of cost involved for training and your digital infrastructure. And also, you need to make sure that your digital records that you are providing to the software is accurate enough, because that is what the final outcome accuracy depends on. Also, the problem is that sometimes it tends to give a very rosy picture, so it's a over reliance on digital simulation. So you need to tone down the patient's expectations here and make it look very realistic, simply because sometimes patients expect the moon in the sky when you're doing all of these things. So you need to make sure that you are toning down the expectations. And also, patients with severe skeletal discrepancies, you really can't help much with these kind of softwares. It's mainly dental related only. Indications is mainly in smile corrections and aesthetic rehabilitations, or any kind of workflow in the aesthetic zone, or full mouth rehabilitation with your digital planning. So all of this can be done with the DST protocol. So these are different software systems which are available and which we use. So I personally use the Exocad Smile Creator and the DTS Pro or DTS Pro 3D. So this is one of the cases which we had done, where we did one of this patient's work. Now the patient was complaining of a prosthesis which was too large. Now we have, this is a case in progress. So this is how we sent across the intraoral scan as well as the facial photographs, and this was planned in Exocad, and then we went ahead and did a design and we showed it to the patient, and we also generated a 3D model for the same, and we're going to use that when we are going to temporize this for the patient. Similar case with DTS Pro. This was another software that I used. This is a case of full mouth rehab. So this patient, we showed what the outcome could be possibly like, and this was the final outcome that we delivered. You see that it's not too far away from what we predicted. So this is how it helps in patient conversion as well. Next, we come on to 3D printing. So 3D printing basically enables patient-specific solutions by building additive manufacturing by layer-to-layer application, which is generated from your digital design. So just like how you have CAD milling, which is subtractive in manufacturing, you have 3D printing, which is additive in manufacturing. So you are able to seamlessly integrate this whole thing with the digital workflow. And the advantage with the 3D printing or additive manufacturing is that there is very less amount of wastage. So this is how your 3D printer looks like, and this is the 3D printing output. So you use it in a very wide array in of applications in dentistry, right from implants, prosthetics, orthodontics, and surgical guides, as well as now we even have printers which are printing tissues. So we don't know what the future holds, but as of now, it has started to print epithelium as well. So these are different types of 3D printers which are there. We have material extrusion, vat polymerization, powder bed fusion, and jetting. Now, these are the first four that I have mentioned are the ones which are most commonly used in dentistry. So the FDM, or what we call as fused deposition modeling, is basically older type of 3D printing which was there earlier, which creates three-dimensional objects by melting and extruding a thermoplastic filament layer by layer onto a build platform. So here what happens is that there is a spool of this material which is running across a heated filament here, and that this heated head will extrude this material into a nozzle which can build up layer by layer. Now, the problem here is that though it is very reasonable in terms of the machines involved, the final output does not have the same kind of resolutions because it's very primitive. So you could use it for generating study models or something like that, but otherwise, if you're looking at fabricating a processes, this is not a very ideal technique. Then came stereolithography. Now, stereolithography is another older technique which was there. Now, here what was happening was that the resin was there in a vat. Now, there was a laser beam which was coming in and curing this resin part by part. So, there was one part, this whole resin was cured by using one laser beam. So, though this technique was very good in terms of its accuracy, the problem is that this technique took a lot of time because though it gave very good resolution, the amount of time that this material took for fabrication, this technique took for fabrication, was far too much. So that is where digital light processing came in, which was much faster because the entire light beam was projected onto a mirror, which was then beaming up the light and curing the whole resin in one layer. So it was much faster, but there was some amount of compromise, is that there was a reduced amount of resolution. So in terms of accurate prosthesis, you can look at SLA as a printer, but if you're looking at a little bit of a compromise but faster turnaround times, you can look at DLP as one of the output. Now here, this selective laser melting is mainly used for metals or metal frameworks. So you have this powder bed which is there. This is called as powder bed fusion technology. So there is a metal powder which is applied onto the bed there, which onto which a laser beam is directed, and high precision and strong dense parts are manufactured using this melting of this powder onto it layer by layer. Now, after every layer is melted and fused, the bed goes down a little bit by a fraction, and then the next layer is printed, then the next layer is printed. So that way, the whole process is built in. So this is a table of the different technologies that are available in the market today for 3D printing. So this is how your 3D printing workflow goes. So first you acquire the data using scanners or CBCT image. Then you convert the data by scans. Then you have a digital. Then you import this entire data into a CAD software, which is either ExoCAD or whichever software you are using, and then you are going to design the whole processes, and then you're going to print it. Now printing basically is going to be done by a printer. Once the material is printed, then you do something called as post processing. So post processing is basically removing the excess unwanted resin, and you are going to clean and cure it. So cleaning is done in isopropyl alcohol, whereas curing is done in a UV curing unit. So this is how a printed model looks, and these are called as supports because these supports are necessary so that the material does not warp or undergo distortion. Now, application, the advantage is that they are used in custom dental processes like crowns, bridges, dentures, guides, orthodontic appliances. And the best part is, they reduce the amount of wastage, and they enable a good amount of production. So it makes the workflow a lot more faster. You are able to generate a crown in much less time compared to that of your milling, plus with reduced wastage. So, in terms of recent research, the accuracy of it, both 3D printing and milling achieve good fit, but 3D printing has much lesser amount of marginal discrepancies compared to that of milling. And efficiency is that they reduce a lot of chairside or lap time by almost 29%, and material wastage is significantly reduced. So in terms of physical properties, they have very good physical properties, and they have good flexural and compressive strength with lower water absorption than conventional polymer with acrylate, especially when you're 3D printing it. So outcomes and outputs are far superior when you're looking at 3D printed. Though literature is a little patchy, it says good in certain ways and bad in certain ways. So yes, there is a learning curve also associated with this particular thing. Then you have virtual articulators and digital jaw tracking. So here basically you have your softwares which are doing the job of the articulator which is incorporated into it. So you are able to record these data extraorally, and then you had to transfer it in, put the numbers into the software. But nowadays you have these jaw tracking devices like modjaw, and you have something called as metismile, which enables you to record the oral scan, and then you have these two touches which is locked onto the upper and the lower jaw. So if you are seeing the scan here, once the touches are in the upper and the lower jaws, you are able to do the facial scan simultaneously. And the patient is asked to do all the mandibular movements. So the entire data is recorded and transferred into the software itself. So it reduces burden of recording a face bow, transferring a record, all of this simply by using these kind of clutches in the patient's mouth. So this is how we go ahead with your virtual jaw recording or 4D jaw tracking, what we call. Next, we come on to artificial intelligence. So AI has taken over most of most of the software features in Prosto. Now, especially when you're looking at a crown design, your AI will generate a crown design based on your other crown shapes accordingly. And similarly, even tooth setup in dentures is also done by using AI nowadays. Also helps you to determine the margins and delineate it. And also there are a lot of as we speak, there are newer techniques and technologies which are incorporating AI to a very very wide extent. Your entire software like your exocad and serec and 3shape is now banking on AI to help you streamline the whole process of you fabricating a crown. So it will just with a click will help you generate a crown in no time and with minimal effort. So these are different areas where AIs are being applied. Then we come on to navigation surgery. Then we come on to navigation surgery. Navigation surgery is basically something like a GPS. Now, if you're, I spoke about static guided surgeries. Now, when you're looking at navigation surgeries, it's basically having a tracking system which is there in a patient. And here, there is a fiducial marker which is put on on the patient's head as well as your handpiece. So what it does is your CBCT data is integrated into the software, and then it is able to give you a real time feedback on how you are moving. So basically, just like how you put a target for a map in a Google map and say, I want to go there, and this map leads you. Exactly the same way, your navigation surgery will give you a real time feedback on where your drill is, how it should be, what is the position, all of this, so that your final planned placement position is achieved. So, unlike static guided surgeries, where you have your static guides which are present there, your this one navigation surgeries will allow you to manipulate it in real time or do adjustment. So in terms of your sustainability and patient centered trends, we have eco-friendly prosthodontics because we have a lot of gypsum which was coming earlier, which is and wax. and but now it is more of resins. So we need to make sure that we are thinking about the future and seeing how we are able to dispose of these resin materials. So that is where it trend is moving towards recyclable materials, or what we call green dentistry, because we have to make sure that whatever we are generating as waste is able to have a biodegradable property as well. So environmental impact is huge. So we need to make sure that we are able to, have more sustainable materials which are coming in. So in terms of summarizing it, materials, techniques, and technologies. In materials, we covered zirconia generations, bio-HPP, hybrid ceramics. Techniques, we cover guided surgery, PET, stackable guides, remote anchorage, and zirconia implants. In technology, we covered intraoral scanners, DSDs, face scanners, jaw tracking, 3D printing, and AI. And in future, we have robotics and sustainability focus. So, in conclusion, in the recent years, prosthodontics has rapidly evolved, driven by innovations in materials, techniques, and technologies. So, we have newer materials coming in every day. Cutting edge technologies are coming in, like guided surgery, PET, and stackable guides to enhance precision, efficiency, and minimally invasive outcomes. So we have technologies which are now seamlessly integrating into each other. So we are only expecting better outcomes and reduced turnaround times as and when we progress. Together, these advances not only improve clinical outcomes but also makes treatments faster, safer, and more predictable, heralding a new era in patient-centered prosthodontics. So I thank you all for your patient listening, and I hope this has been of some help to you. And any questions, you can direct it to my mail ID, and I'll be happy to share my answers with you. Thank you very much, one and all.